Hey there, welcome to another video on math problem solving. This is the third part of the problem that we discussed over the last 2 weeks. If you haven't seen the first two parts, please do so that you can get the context. But to give you a brief idea, this is the problem. The LCM of three numbers, we're actually taking two at a time. So LCM between the first two numbers A and B is 1000. LCM between the second and the third number B and C is 2000. And LCM between the first and the third number A and C is 2000. And the question is about finding the number of ordered pairs A, B, C. So to do that, in the very first part, I looked at how you can intuitively understand LCM in terms of the prime factors. And in the second part, we did a subsection saying, can we prove that at least one of the number has to be a multiple of 14? Giving us insight into understanding how the factors play out, or the power of the factors play out. Today, we're going to be doing the next part of the sum, which is how many ordered pairs are there. So we can think of the three numbers to be A, 2 to the power x1 times 5 to the power y1, and B to be 2 to the power x2 times 5 to the power y2, and C to be 2 to the power x3 times 5 to the power y3. Right? So this is going to be it. And you know that A and B together has an LCM of 1000. B and C together has an LCM of 2000. A and C alone, taken separately, has an LCM of 2000. So if A, and let's focus on one prime factor at a time. So let's begin with 2's first. So we're just looking at 2's. Then I know that between A and B, in other words, between x1 and x2, at least one of them needs to be 3. Right? And between x2 and x3, at least one of them needs to be 4. And between x1 and x3, one of them needs to be 4. So from the proof from part B that we solved was that x4 always needs to be 4. Sorry, x3, that is the power of C, always needs to be 4. That's the only way you can get the LCM to be 2000. So if x3 is always 4, that's a certainty. You can kind of replace this and say C has to be 2 to the power 4 times 5y3. Which means the only possible combination or different varieties of numbers that you can see is going to be between x1 and x2. And we know that between the two of them, at least one of them needs to be 3. So let's write down all the possible ordered pairs just for x1 and x2. So if I have x1 and x2, x1 can be 0, 1, 2, or 3. But provided x2 has to be 3. And similarly, x2 could be 0, 1, or 2. 3 has already been counted, provided x1 is 3. So in total, there are 7 different ways of choosing x1 and x2 so that still, the LCM conditions holds true. So there's 7 different ways. Now let's do the same thing for the prime factor 5. So in case of 5, we know that between y1 and y2, one of them needs to be 3. Between y2 and y3, one of them needs to be 3. And between y3 and y1, one of them needs to be 3. This is the only way you can get to a factor of 125, which is necessary to get to the LCM that's given. And if you pay attention to this, you'll realize that this can be thought of as between y1, y2, and y3, at least 2 of them are 3. Okay, 2 of them are 3. This is going to be a necessary condition. So let's take, for example, how to break this. Let's assume y1 is 0 and y2 is 0. Then this fails, this condition fails. So even though y3 might be 3 and these two conditions pass, the first one fails. So between y1 and y2, one of them has to be 3. And if y2 is 3, then you can conclude that y3 need not be. But for this condition to be true, and we already know y1 is not 3, which means y3 has to be 3. So what are the different possible ways that we can reach this? We can think of it as y1 could be 0, 1, 2, or 3. And y1 can be 0 only if y2 and y3 both are 3. This is the only way you can achieve this. So this is your common condition, which is going to apply whenever everybody is 3. It's also possible that y2 could be 0, 1, 2, or 3, but 3 is already counted. It's also possible that y3 could be 0, 1, or 2. But for y2 to be 0, y1 and y3 both need to be 3. And for y3 to be 0, y1 and y2 both need to be 3. So you can think of it as every single number can be 0, 1, 2, which means 3, 3, and 3, and one condition where all of them are 3, which is common, which is 1. Add them up, you get 10. So now, in order to find how many ordered pairs A, B, C exist, how many three numbers exist such that the LCM is under this given condition, can be determined by multiplying the two, which is 70. So that's the answer to our question, which started off with this. So I have three numbers. The LCM is such that it's 1000, 2000, and 3000 when the numbers are taken in pairs. How many such ordered groups are there? A, B, C exist, and the answer to that is 70. 70 is the number of ordered pairs for A, B, C. I hope you found this video insightful and informative. If so, please do like, share, and subscribe, and I'll see you in the next one. Thank you so much.